Today I want to talk with you about RPC centralization and what it means for our industry. So just to introduce myself, my name is Slava, I'm CTO at the RPC, and we're building decentralized RPC infrastructure for the multi-chain future. So, what's RPC again? Maybe you haven't heard about it, but if you haven't heard about it, you probably heard about blockchains. And if you know, blockchains are probably like, it's just a fancy way to synchronize state between different computers in a decentralized and permissionless fashion. But the most important stuff in blockchain is a state. So if you're building any kind of dApp or Web3 application, you need to access this state. So typically, each blockchain client has some kind of API that allows you to query this state. And why do we call this RPC? Because it's like API. Well, historically, Ethereum and Bitcoin went with JSON RPC protocol, and the term kind of stuck. So originally, of course, everyone imagined that if you want to write your own dApp, you would just run your own node. And this is a perfectly decentralized way to do stuff. However, we live in 2024, and this is a multi-chain future where running, if you support 30 protocols, running all the blockchain nodes is just not feasible. It's too expensive, and basically nobody does that. So naturally, a type of company appeared that we call right now RPC providers that are basically typical software as a service company, Web2, web software as a service companies. So we're building decentralized web on top of centralized software as a service company, but temporarily, right? Well, let's try to think about it. And first, let's ask ourselves a question. What do those RPC customers, clients want? Well, they, of course, want good user experience and developer experience, high speed, high reliability, and low cost. So what things they don't want? They actually don't want decentralization, and they don't want fancy technology with bad developer experience. And it's understandable because, we're talking about Web3 companies. They have their own customers, and they should care about them. And, they can't say, last day we were down for 3 hours because of our RPC provider, but, it's decentralized. Their customers will probably go to their competitors that can probably use centralized providers. So centralization on RPC layer is a status quo. It's not because we are bad industry or bad people. It's just because it's the most efficient and easiest way to achieve desired properties that customers want. OK, but why would we even want decentralized RPC? And let's try to be honest about that. Well, maybe user experience and developer experience for decentralized RPCs is better. You probably know the answers, that decentralized RPCs historically perform in terms of user experience very bad, and centralized RPCs and, in general, centralized applications have better UX and DX. OK, so that's not it. Maybe they have better reliability. Well, there is an argument that decentralized RPC providers are kind of running for a while right now, that we, decentralized RPC providers, don't have a single point of failure, so we're more reliable. But unfortunately, every decentralized RPC provider I know also runs centralized gateway. So it's kind of, effectively the same thing as with centralized ones. Again, it's not because we want to lie to you. It's just because everyone wants good developer experience, and it means they just want to copy-paste the link from your website, and that's why we need centralized gateways. OK, so maybe decentralized RPC providers have better performance. Again, you could argue maybe that in decentralized protocol you can have on board a lot of projects from all around the globe, have better latency, but I would argue that centralized providers can do it too, can have servers everywhere, and in theory they can even reach better performance than decentralized because they control everything. They control hardware and networking, and then can build a setup that is, in theory, more performant than the decentralized one. Then there's verifiability. It's a common argument in the discussion between centralized versus decentralized RPC provider. And the core thing is that when you use some kind of RPC provider, you kind of trust them. Because you don't have any means to easily verify their response. So nobody cares a lot about that until, of course, something bad can happen. For example, one day you go to some very important project, very important vote, And in this moment, our RPC provider decides to tamper with the data and, for example, change the voting title. And you can end up voting for the thing you don't understand or don't agree with. There are a number of ways how you can protect yourself. First and obvious one is light clients. So light client is a super efficient node that you can run on your phone, run on your in your browser, and you basically can use it as a RPC node for your Dapp. You connect to this light client, and this light client connects to your RPC provider, but it does some fancy stuff that allows it to verify each RPC provider response. So you kind of protect it from this tampering. There are existing solutions right now for Ethereum. Two of them are Kevlar and Helios. However, there are a number of problems with them. First, as I said, when you send a request to light client, it translates your request probably into several requests. And this will be more expensive for you. It will take more time. And so a lot of applications do not want that. Also, of course, not all requests can be verified this way. And the last thing is not all the blockchains support light clients. Ethereum does, but many more don't. You can imagine some solution using ZK magic. Probably you can imagine that our RPC provider can send the ZK proof along with the response, and you can verify it. However, technology is not yet there. It's computationally infeasible, and I struggle to imagine how it can be done universally across all blockchains. And the last one, quorum check. You kind of can send the same request to different RPC providers, check if they agree with each other, and if they do, probably their response is correct. So you can see all of those three ways to battle this verifiability problem. However, it doesn't matter whether you work with decentralized or with centralized provider. It works either way. You can argue that in decentralized setup, you kind of can punish the providers who try to lie to you. However, it's not really important in my opinion. So far, things don't look good for decentralized RPC providers. So what about cost efficiency? And I would argue cost efficiency is really better for the centralized providers. There are several reasons to that. First is that when you have this decentralized RPC provider, there's basically a protocol, and there's protocol participants, node runners, who run their nodes for you and participate in the protocol, and they can squeeze more juice from their setup because, for example, they can participate in several protocols simultaneously and use different resources. For example, their server can have GPU, CPU, and they run the node, participate in graph indexing, and maybe some GPU sharing stuff. So the second one is if you have any kind of price auctioning inside a protocol, you can have significantly more efficient price discovery mechanism because all of those node runners will compete with each other. Yeah, the centralized providers also compete on price. However, the problem is that there are not a lot of them. And the thing is that it's not always about price. There's general stickiness to the platform. There's BD, there's marketing, PR, all that stuff. So the price discovery mechanisms will never be as efficient. OK, so what about multi-chain? Does multi-chain better for decentralized RPC providers? Yes. The thing is that when you are a centralized RPC provider and you want to onboard new blockchain, you need to first rent some servers or buy them. Then you need to learn how to run this new blockchain stuff. And then you need to add some code to your UX and your load balancer to support the new protocol. However, in decentralized RPC provider, we just need to support this protocol on load balancer level, and that's it. And then we can find some people who are already running those nodes, or at least know how to run them, or at least have some spare time to learn it. So that's why this is why we were able to support 63, I think, blockchains right now, far more than any RPC provider on the market right now. And the last and most important thing, in my opinion, is censorship. And censorship on RPC layer is not unheard of. We've seen instances of that already, but I argue that it's getting worse. So there is a recent paper from a group of legal researchers that they want to provide a framework for battling illicit flows, illicit activity in DeFi. And they argue that, in TradFi, battling illicit activity is all about intermediaries. So you can implement some measures on intermediaries, and if you control intermediaries, you kind of control illicit flows. And they correctly identify that RPC node in DeFi is the ultimate intermediary. All read and write requests go through it. So they define CCT, Critical Communication Transmitter. Basically, every commercial RPC provider should be CCT, and then you can require them to implement risk management practices and procedural reasonably designed to help mitigate illicit finance activity in ways tailored to their operations, which is basically implement censorship mechanism. Can it work? Well, first I must say that battling illicit activity in DeFi is a noble goal. However, imagine there is a hacker and they want, they stole some money from the protocol and they need to send few transactions. Would it be hard for them to run their own node or find uncensoring node? I would argue no. But if you're a big DEX or a big Web3 application, it couldn't be hard for you to, mitigate this censorship. So you would have 3 options: run your own nodes, use unregulated providers, or submit to censorship. And we know, like we previously talked, that running your own nodes, if you support 30 blockchains, is not viable. It will probably kill most of the project that will try to do that. So then there's only 2 options: running unregulated providers or submitting to censorship. And it's hard to say how it will play out. However, remember, in RPC market, everything is about performance, reliability, stuff like that. So market leaders who excel at this, they will probably comply immediately. So you are left with those who are worse in many ways. Privacy, security, all that stuff will be worse for the unregulated providers. You can compare this with the, for example, free VPN situation, where you can use free VPN, but they will gather data about you and sell it to someone. So maybe the only way will be just something to censorship. And again, for centralized providers, there's actually not a question to comply or not. They will eventually comply, maybe just comply or cease operations in country of regulations. However, for decentralized providers, it's a little bit more complicated. Remember, there are node runners, and they can decide for themselves. And you could argue, yeah, but you have centralized gateway, and if it will implement censorship, it doesn't matter. However, if you have a community of node runners unified by a protocol, you can have multiple gateways. Some of them will be censoring, some of them will be not. And you can compare this to situation in Ethereum block, transaction censorship. It's enough to have just a small fraction of non-censoring MAV relays, non-censoring block producers to non-compliant transactions to pass through. So if we will have at least 10–20% of node runners and gateways to be non-censoring, this will make those regulations inefficient. Okay, so let's look at everything we discussed so far. So if we're building decentralized RPC provider, we probably have better cost efficiency, we have better multi-chain, and of course, we have censorship resistance. Verifiability goes both ways. And for centralized providers, you have better UX, DX, better performance, and better reliability. And if you remember what I was talking in the beginning, centralized providers are actually winning hard. So if we don't do anything, we have a future with extreme centralization and censorship mechanisms. So what can we do about it? Well, the real question is, can we get everything? Can we get best of the both worlds? Censorship resistance from decentralized world and good metrics from centralized world. That's what we're exploring at the RPC. So our goal is to understand whether we can build a decentralized RPC provider that is on par or better than our centralized counterparts. That's why we, for example, focused more on the gateway. We saw some project that already built permissionless, decentralized node runner set, and we know it's possible to do that. However, we decided to invest more resources into a centralized gateway that will be able to offset individual provider problems, optimize latency, reliability, stuff like that. And I would say that we have a proof of the concept working, and we were able to onboard a lot of cool projects like SushiSwap, Instadap, Lido, and many more. And they all choose us not because we're decentralized and we gain some points from it. It's just because we're better, or at least in some ways better than their previous RPC provider. So So yeah, now our goal to understand how we can push decentralization even further, but we don't want to do it just for the sake of decentralization. We want to understand if it's possible to push decentralization further without compromising quality of service. Because in my opinion, the only way we can have a future with truly decentralized web running on truly decentralized data layer is this way. So we're trying to build this feature at DRPC. And if you want to check it out, go to drpc.org. If you want to follow our Twitter account, you can scan the QR code. That's it for me. If you have any questions, I'm happy to answer.